Hello, I'm Papia. In this problem, we have to compute the arc length of a curve, and the curve is given to us as parametric equations. X equals e to the negative t cosine of t, and y equals e to the negative t sine of t. And we have to compute the arc length in this interval from 0 to pi over 2. So recall, when you have a curve given in parametric form, to compute arc length, we usually use S for arc length, and this can be computed by using a definite integral from a to b, dx dt square plus dy dt square, whole thing under square root, and then dt outside. So this is the expression that we can use and integrate, find the definite integral of this to compute the arc length. So given x and y in terms of t, we can compute dx dt and dy dt. So let's do that separately. Then we will find this expression, simplify it, plug it inside the integral, and then we'll solve it. Okay, so let's come back here and figure out what is dx dt. Okay, so look, x is given as a product of two functions. So when you're taking the derivative, we have to use the product rule. So let's do that. First, you keep e to the negative t fixed and take the derivative of cosine of t. That's negative sine t. Plus, you keep cosine of t as it is and take the derivative of e to the negative t, which is negative e to the negative t. Okay. Similarly, compute dy dt. It will be very similar. It's also a product of two functions, so we again have to use product rule. So let's keep e to the negative t fixed. Derivative of sine of t is positive cosine of t, plus keep sine of t fixed, and derivative of e to the negative t is again negative e to the negative t. Now note, we have to square this and then add them. So let us figure out what will be dx dt square plus dy dt square. Okay. Let us write dx dt and simplify that expression. So look, in dx dt we have two terms and we have a common factor of e to the negative t. So let's pull out e to the negative t from both terms, and we will be left with negative sine t from the first term and negative cosine t from the second term. Okay, so we are squaring this entire expression. Then plus, we have to square dy dt. Okay, let's do the same thing with dy dt. You see both terms again have the common factor e to the negative t. So if you pull it out, you will be left with cosine of t from the first term and negative sine of t from the second term. Okay, let's try to simplify this. Okay, so you have two factors in the first term and you're squaring the whole term, so you're squaring both terms. So first term becomes e to the negative 2t. And notice that negative sine t, negative cosine t, if you pull out the negative sign and you're squaring it, the negative just goes away because negative squares is positive. So this is just sine t plus cosine of t square. From the second term, again you square both factors. So e to the negative t square is e to the negative 2t, and just cosine of t minus sine of t square. All right, let's simplify further. Now, from these two terms, you see that we have a common factor of e to the negative 2t. Pull it out, And let's see if we FOIL sine t plus cosine t square, what do we get? Well, we square sine t, so we'll have sine square of t plus 2 sine t cosine t plus cosine square t. That's only from this first term. Then you are adding cosine of t minus sine of t whole square. So this is from the first term. Then we will add the square of this particular factor. Okay, so do it again, FOIL. We'll have cosine square t minus 2 cosine of t sine of t plus sine square t. Okay, remember all these terms are added together. So if you notice carefully, we have a positive 2 sine t cosine t and a negative 2 sine t cosine t. So these two will cancel right away. Okay. Now notice what we will be left with. Okay, we have e to the negative 2t. Okay, look, we have a sine square plus cosine square. Do you know what sine square t plus cosine square t is? It's just 1. That's one of the trig identities. Okay, so sine square t plus cosine square t will give us a 1. And then plus, from the next term, you will have a cosine square t and a sine square t. Again, those two added together will give you another 1. So this whole expression is simplified to 2 times e to the negative 2t. All right, let's bring it here and plug it in this definite integral. Note that the definite integral, these limits are the limits for t, and the interval is from 0 to pi over 2. So this will be integral of 0 to pi over 2 square root of this expression dx dt square plus dy dt square is what we have simplified to be 2 times e to the power negative 2t dt. So let's solve this integral. Well, you can rewrite the square root as square root of 2 times square root of e to the negative 2t. That way we can pull out the square root of 2 outside the integral, and look what we get here. This is square root of e to the negative t square. So you can get rid of the square root. So the simplified form is, you can pull out the square root of 2 outside, and this is square root of a square. Simplify, this is just e to the negative t dt. And you know how to integrate that. So the antiderivative is negative e to the negative t. And plug in the limits. So pull out the negative sign outside, so it's negative square root of 2 times, plug in pi over 2 for t, so you get e to the negative pi over 2, minus plug in 0, e to the 0 is just 1. Finally, if you want, you can pull the negative side inside, and you get the answer square root of 2 times this 1 becomes positive, and e to the negative pi over 2 becomes negative. So this is the arc length of the curve that's given by these parametric equations. If you want, you can use a graphing utility to see that this is almost 1.12. So 1.12 is the arc length of the curve given by this set of parametric equations inside 0 pi over 2. Thank you.